Okay, Lady Ada, what is this?
Hey, everybody, and welcome to another Wednesday night show and tell. It's me, Lady Ada. With me is Mr. Lady Ada. We are here at the Adafruit factory in downtown Manhattan, where we make all the electronics that you know and love. But for the next half an hour, we're going to be hearing from you, the makers and hackers and creators, as you show off and tell us what you're up to. We're here till 7:50 p.m. We'll be calling you, unmute your mic, show us what you're working on, and then mute your mic back up, and then we'll get to everybody because it can be quite a party.
You never know.
Start off with some Adafruit peeps with Noah and Pedro. Let's kick it off.
Hello.
Hey, what's up, everybody? This week, we have a USB controller. It's a foot switch, fully 3D printed enclosure. It's powered by the Adafruit Trinket M0. It's CircuitPython powered. Really simple design. It has like a little pivot point here. They kind of snap off, connect that way. It just has a zippy micro switch, which does the actuations. And like I was saying before, the Trinket M0 running CircuitPython. So it does one thing very well. It executes a key command. And I'm using it for doing overhead photography, but other folks could use it for all sorts of different things. So that's it. It's 3D printed. We talked about it for about an hour on the 3D Hangout show this morning. And it's a foot switch.
Yeah, but it works really well.
The number one look really well.
The question is where to get spring.
Everyone wants to get where's the spring? You don't need one. It's built into it.
There you go. See?
Spring.
The trick.
Woo. Yeah. Premium zippy button.
You have a spot if you wanted to add a spring.
I do, and it's parametric as well. I talked all about that. There's a little holder thing that you could put a spring in there, but all the compression springs come with different diameters. So I figured I'd turn that into a user parameter driven thing feature in Fusion 360. So open source file if you guys want to modify it.
Yeah, those features are pretty durable. I mean, you can just use that as the weight, as long as you don't like smash it with your foot.
And surprisingly, without the spring, it requires maybe a gram of force to actuate. So it might work really well for assistive purposes. Like a Bill's been like, yeah, maybe.
Yeah, I mean, it's
well, 2 thumbs up.
Elegant.
Yeah.
All right, well, thanks for the update.
Yeah.
The video for more details.
Yeah, we'll be playing all your videos tonight on Ask an Engineer.
Thank you.
All right, next up.
Happy first day of spring.
Happy first day of spring.
Okay.
Spring.
Let's go to Scott.
All right, Scott, what rat hole are you down now?
Well, I was in the synthesizer rat hole, and I managed to get myself out. I have been working on audio stuff, so that's my day job, which is good. But what I was up late last night working on is my CircuitPython powered toaster oven. This is obviously just the control panel of the full oven. But what I was testing is actually I transplanted the LCD from the original oven onto my board, and I wanted to see if I could get it all working. So in here, this is where the knob is usually, but I made all of the stuff that I want to have accessible available there. So I've got a USB, and I experimented. It's Type-C as well, so I don't need to like worry about what orientation it is. I can plug it in, and the buttons light up. And I don't know if you can see it. So it says, oh, the drive loaded, so it restarted. There's dot stars behind the start button, so that's why it's flashing between red and green. And then what I can do is I was just experimenting with the different segments on the custom LCD.
Oh, preheating.
So it says preheating, but if I hit up, it's like a particular segment of the 7 segment, and it just restarted again.
Mm-hmm.
And I can click through there. I don't know what that says. Something else having to do with a toaster. Slices.
Yeah.
Yeah, so I was playing around with that, just trying to figure out like how everything maps together. It's running the latest CircuitPython 3.0 because it's actually an M4. It's a SAMD51 on here. Which is a good segue to, if you're really interested in CircuitPython and want to experiment, you should try the alpha of CircuitPython. It's most of the way there, so it's most of what you're used to. And having people test that is really good. We'll squash all the bugs early and often. And then lastly, we revamped the CircuitPython weekly. Well, it was called Python for Microcontrollers. It still may be on the checklist. But the Adafruit Daily, which we actually send out weekly for Python, has been revamped. So people should also subscribe to that. And if you're interested in contributing, so if you have news stories about Python, MicroPython, CircuitPython, or cool projects that you've done with those, please let us know. We have a new GitHub repo that you can find where you can actually just change the draft of the next weekly newsletter.
Ooh, submit pull requests to a
There
newsletter.
will be things in the newsletter that are found nowhere else.
Yes.
So subscribe.
All right, thanks for the big update, Scott.
Okay.
No problem.
All right,
Except JP.
hey, JP.
Hey, everybody. So we've got a whole bunch of guides up for AdaBox 07, and I hear that some people are starting to get their boxes in the mail, which is very exciting. I would caution you, if you want to be surprised when you get your box, don't go to the Learn Guides and check out what's there, because you may end up spoiling the surprise a little bit.
Or Twitter, but that's just general good information sometimes.
Yeah, don't look at things. Now, if you have missed out on that one, I want to mention, I think that you can start subscription for AdaBox 08 now. We're accepting subscriptions. But in a couple of weeks, I'll be doing a live unboxing of AdaBox 07, show you all the good parts in it and a bunch of things you can do with it. A little sort of hint and tease towards that I wanted to show tonight is a bit of a tip. And that is, I've been doing some projects where I'm using the keyboard or mouse HID output of the Gemma M0s. And so I'm essentially containing little self-contained gizmos, sneaky little gizmos using a Gemma. And I wanted them to be a little more discreet. So what I found is that a 3/4 inch diameter piece of heat shrink tubing fits really nicely around a Gemma M0 and makes it this kind of neat little package where you can still plug in USB on one end or a battery on the other. This is what it looks like when you buy at the store. A lot of audio installers for cars will use this stuff. I got it in black and in clear. So here's one in clear. So if you wanted to still see the lights, but make it a little more rugged or waterproof, resistant, I should say. And on this one, I even cut out the little switch hole so that I can turn that one on and off. You can still use your reset button. So it's kind of a cool way to extend sort of the durability and function for these guys. So that's my little tip, 3/4 inch heat shrink tubing. Check it out.
Yeah, not to give AdaBox 07 away, but the tweet we got was envious of my 6-year-old girl's AdaBox 07 subscription. Well done. So thank you, JP, for all your work on that.
Super.
All right.
We'll see you.
Phil
Oh,
B.
and a quick plug. I'll be doing one of these related projects tomorrow on my live stream, 4 o'clock Eastern time. I'll be making something groovy and fun.
You're going to be on Make Live too, right?
Oh, yeah. I'll be on Make Live at 7 p.m. Eastern time, 4 p.m. Pacific, which is Make Magazine, sponsored by DigiKey, is going to do a build. Tyler there at Make is going to do a live build of my Pizza Box DJ controller that I did with CircuitPython a year ago or so. And so I'm going to be on the live stream to help him out if he needs any. And
You're going to be on both Maker networks, MBC and ABC.
lots of Make tomorrow.
Yeah.
Lots of Make.
There's so much going on. We can't even remember it.
It's crazy.
Tune in.
All right.
More JP.
Next up, Phil B.
Hello there. Hey, thing we've had in the shop in the past, it's kind of been missing for a long time. You know, the Cupcade kit, the little adorable Pac-Man looking machine. This kind of dried up because it was very hardwarily built around the Raspberry Pi Model B, which is, you know, doesn't exist anymore. So I've been working on a refresh version, looks very similar externally, which will work with, you know, if you have a Pi 2 around, or work with a Pi 3. Not yet the B plus Pi 3, but that's just a software thing. When RetroPie is updated, the latest Pi will work in here, and has an upgraded speaker and stuff. So that'll be a thing soon in the shop. I'm not exactly sure when, but
It's not out yet. Don't ask.
yeah, not out yet. But it'll be nice
It's
because
happening.
it'll be like, you know, current Pi hardware running running all the games and stuff in the little cabinet. Something I'm playing around with right now, though, I think this is kind of cool, is even if you have the old kit, I'm updating the software right now, so you'll be able to put, you know, the latest stuff on here. It used to just run like MAME kind of poorly, and NES, and that was it. But now, because it's based on RetroPie, there's like a whole bunch of different stuff you can emulate, and that'll work even if you have one of these original Cupcades. So I'm working on the guide right now, so I wouldn't say like go in there and jump on this right now because it might not work. So I'm going through the tutorial, making sure all the software works, and probably by tomorrow, you know, if you have an old Cupcade, you'll be able to have refreshed software that works on it.
Okay, thanks for the update.
All right, thanks for the
Yep.
The most modern ways to run old stuff. State of the art. All right, Isaac.
Hey, Isaac, unmute your mic and show us what you got.
I made a tilt trumpet this week with the Circuit Playground Express. So you just play the notes based on how you're tilting the Circuit Playground, and you kind of hold it like a trumpet to play the two buttons. So you have one button plays the lower notes, and the other button plays the higher notes. And if you tilt it one direction, it gets quieter, and then louder in the other direction. So you kind of have some more control.
Oh, cool.
It doesn't sound incredible because the speaker, but it's kind of fun to play along different songs. Kind of a fun little instrument.
It looks cool, and it also looks like one of the instruments from like the Star Wars bar scene where they're all like,
Yeah.
Good work.
Aliens.
Thank you.
Alien music, tilt trumpet.
That's way better than the flute that was in Alien Covenant when they had to play it. And anyways, that movie got dark. Okay.
Is this is this an Express or a Classic? Just
This is an Express, and I actually made this is the first time I used MakeCode, and it was actually way easier than Python from what I'm used to. So I was able to hack it up pretty quickly. With
MakeCode
and everything.
Drag and drop. It's super easy.
Yeah, I'll make a guide later this week.
Oh, sweet.
Pretty fun, yeah.
Yeah, I owe you an email as soon as I get off air later.
Sure.
Okay.
Okay. Thanks, Isaac.
All
Thank
right.
you.
All right, don't
Next
forget your
up-
show and tell sticker. Email support Adafruit.
Got it.
Next up, Bill.
Hey, Bill.
Hi guys, how are you? Can you hear me okay?
Yeah.
All right. So I ran back here from David's house, the hotel room, and set up very quickly. So I hope everything works here. So I was going to show what we were doing out here in Sacramento. I'm kind of on this big road trip. I went from Tampa to Sacramento, and we've got a conference. But I also worked with a gentleman today who wanted to be able to control his own suction device, so a saliva suction device. He worked for about 7 years to try to get them to add a jack to let him do that, and they failed him. So he sent me one, and I added the jack, and I've got great video to show, but I couldn't do this live stuff from his house for a variety of reasons. So I'll send that to you, and you can show it maybe next week's Ask an Engineer.
Yeah.
But my next stop is in Seattle, and I'm actually going to meet up with Scott, I believe, I hope, up there as well. But we're going to go to Seattle, and we're going to show this device, this is my last chance to show you, which is why I rushed back here. And it's kind of cool. So I'm sorry about the horrible camera work today, but I am in a hotel room, so you'll need to bear with me here.
Well, you just set the bar really high. You have like a studio at home and everything. You're fine. This is
I
perfectly
love
okay.
the generic
This is perfectly
hotel
okay.
art in the back.
Yeah,
All right,
that's a green screen.
All right. So here's my lovely camera here. Let me see if I can make this work. All right. So this device is going to be dropped off with a gentleman in Seattle who is going to. He currently uses a sip and puff switch to be able to control to be able to type. He uses Morse code to sip and puff dashes and dots and type. He's got a C3 injury in his spine, and his problem is he can only control one device. So he wanted to be able to control more than that. So you'll see this device actually has 2 switch inputs, and over on this side it's actually got three pairs of 2 outputs. So what this box does basically is it lets you switch between multiple devices. And you'll see it's a kind of a train wreck, not just on the focus, but it's got a lot of wires involved. It's got 4 relays, and then it's got a feather and a little INA 219 current sensor. And so the reason for this is that he goes so fast on the Morse code that he actually can't have a system that reads his sips and puffs and mirrors them on the relays. He actually needs this to pass through the relays to the device, because otherwise the overhead, the lag created by the relays makes him unable to work, basically. So what this does is it actually passes through signals to 3 outputs, and it eavesdrops on one of the signals waiting for a long press. So you'll see an even bigger mess here, right here. This one over here is a test box, and all these wires are just test boxes. So I'm not delivering all these. But I needed a way to be able to make sure this worked. So if you look carefully as I press this button, you'll see that it's lighting up those lights on the neopixel wing there. And if I hold it down, it'll actually switch to the next one, right? So it's actually changing what output goes through. And so as fast as I can go, it goes through. There's a second one here. So there's the second button, and you can't see this right now, but it will actually pass that one through as well. So the idea here is to be able to multiply the number of devices he can control. It's very low low cost here. It'll probably cost me about $50 total, and I'm using a Bluetooth chip just because of what I had around. I will tell you that this is the first device that I think we will create a PCB for and actually create a board for, because the number of things I can do with this board just by changing how the wiring is configured is pretty exciting. So a lot of people want, there's a thing called the switcher out there that lets you switch between what you're controlling, but this gives you a lot more flexibility, and it passes everything through without actually adding any lag, which is really nice.
Looks
So I'm
great.
going to deliver this on Monday, and hopefully Scott will have a chance to see it. And we're also introducing him to a robotics team in Seattle, so hopefully they can help him with the maintenance of this.
Looks cool.
Outstanding. Well, thanks so much, Bill.
Nice 3D printing and electronics work.
You like that? I like
Yeah.
that.
Looks great.
And AT Maker is green too.
Yeah.
Always.
On brand. All right. Next up, Lon. Hello, Lon. Welcome back.
Hey, Lon. Oh, unmute.
Okay, are we
Hey.
unmuted?
Yeah. Hey.
Yay! So we're playing with AutoWire today. I'm using OBS to switch my inputs instead of trying to do the window share. So yeah, I haven't been on in a while. I don't know if I've been on since I got the 3D printer here in my apartment. I got a CR10S, which can print really big things. So that one space gun that we've been working on, hope we'll get that in.
Yeah.
So basically, you print the whole thing in
Wow.
one go. So that's cool.
Huge.
And then other big thing I printed right away after, this is I think the first thing I printed on it after Benchies. And then the next thing was just to test how big this thing can go. Let me show it in my head.
Wow.
Giant vase with some
Great
old PLA.
quality.
Worked great. Let's see what else. The vase. Oh, and then I had to store my filaments. So get my face back on. Wanted to make a dry box, and I wanted to measure how dry the dry box was, so I could test different methods of drying filament and keeping it dry and keeping it warm and all that kind of stuff. So I used the feather with the Wi-Fi on it, and made my IoT dry box, which has well, to keep things dry, I found this really clever thing on Amazon.
Internet of dry things.
Internet of dry things. So I found these, and they're really clever. It's basically the silica gel pearls in a perforated box. But what makes it clever is it's got a heater built in. So it's designed for like gun safes and things.
Yeah.
Where you don't have power. So use it until the silica gel changes color, and then you plug it in the wall, and it will ventilate the area for a few hours, and it bakes off the silica gel, and you're good to go again. And then obviously, so I hooked it up to Adafruit IO, and we can check the status of the box at any time.
Wow. Nice.
So right now it's 10% humidity and 21 degrees.
Wow.
So it's doing a good job.
Exactly why we made IO, because like it just all works with the stuff. Like
Yep. And it was super easy to do. You guys did great job on that.
Yeah.
Let's see, dry box, show the dashboard, switcher. And then I've been doing a lot of streaming on Twitch, doing lots of weird projects, and a project that originated with the chat room. I think some of the ideas is we have our OBS switcher, OBS is Open Broadcast System, I think, which is an open source video switcher. And so I have my high-tech switcher here with the fancy labels and all that, which has all my sources, and I can switch between sources by pushing a button. I'm using a different layout right now for the that I do when I'm streaming, so I can't push the buttons. Oh, so I have my.
You're good. I just gotta mute.
Okay. But yeah, you push a button, and it switches to that scene, and it's got a Teensy 3.2 inside of it. Basically, I'm switching to the Itsy Bitsy for most of the things I would use the Teensy for. So I had an extra one. Kind of overkill because it got, what is it, 30 some inputs.
Yeah.
But we're kind of burning through them, and that's gonna be the last thing. Is the chat suggested that we make foot switches for like the cough drop and that kind of stuff. And so published on the same day as Noah and Reese's foot pedal, I've got my own little foot switch, which is a 3D printed foot switch. You print in 3 parts. You got the base, you got the pedal, and for a spring, I'd originally designed some really fancy spring stuff, but then I realized people with 3D printers have binders lying around.
That's a good idea.
Yeah, they might not have clothespins and they might not have piano wire, but they're going to have the binder clip. And so you can adjust the tension of the spring by where you place this bracket that holds the binder clip. So if you want it tighter, you push it back. If you want it looser, you push it forward. And then we'll go on Thingiverse this afternoon, or this evening when we're done here, is up in front. Well, let's show the full disc again. We've got a snap-in bracket. So everything's snap-in. The only glue is to position this bracket here. But there's a little clip that holds the roller switch. And I'm pretty proud of how that came out.
Okay. Can you come
we're out of time?
Yeah, I just want to get a couple more people come in, Lon, if that's cool.
Yep.
You had so much to show. Come back next week. We want to see more details.
You could do a full thing just on one of those. So keep coming back.
All right. Thanks.
Keep printing large things now. Congrats on the.
I love that, Roz.
All right. So we're going to go to Matthew, and then we're going to go to Billy, and they're going to wrap up with Dana. If each can keep it to a couple minutes, we can get everyone this week.
And friend.
All right. Matthew and engineer.
All right. Hey. All right. So this is my daughter, Aurora. And Rory had. You want to say hi, Rory?
Whoa.
2 of them.
There's 2 of them.
And Rory's got, hey Mac, and this is Malcolm too. And I'm going to show you so I've been using the Circuit Playground with a lot of my students at school. And Rory has this IKEA light, but the problem is that it has this toggle switch that she really struggles with being able to try and like flip it back and forth. So Rory and I worked on making using the Circuit Playground, a touch sensitive pads right there. And so Rory, you want to show how the pads work?
Go for it.
And you show them how it works, okay?
Yeah.
Okay. All right. So we got, do that one again. We missed it. Go a little bit slow. So I think this one's off, right? Did we do it? We got to do a little more testing here, but that one's off, and then turn it back on.
Live demo.
Oh, yeah, right. That was the demo. Yeah, do it again, Rory.
Oh, no.
And so Rory's been doing a great job she coded it herself, and then the circuit and everything was very simple, right? With Circuit Playground. So we just replaced the bulb and everything was right there. And Rory's been doing a great job using make code and then changing the colors. And we're going to add in some more, because what colors are we going to do? Green.
And violet.
And violet, too? So we're going to make lots of different pads on here so she can change the colors for her reading lights. So it's been very exciting of Rory being able to kind of help with making the circuit. And then one of the things that I got really excited about is we've been playing around with these like sticky foam pads that I bought at Walmart. And so just simply putting tinfoil behind, of course, for the demo it didn't work. But these have turned out to be really great because you don't have to mess around with glue at all. So you can just cut the foam pads to the shape you want, slap some tinfoil on, and then just stick it to whatever you want. So it made the whole assembly process very easy.
I'm sure you'll figure it out.
Yeah, this is great. Well,
this is great.
Rory, you get an as seen on the show and tell sticker. So have your assistant email us, and we'll send one out. Okay.
All right, will do.
All right.
Thank you.
Good work.
All right, it's like a party over there. Bye. Goodbye.
All right, next up, Billy. Yay. Everyone likes hacking IKEA. All right. Okay. All right,
So
Billy.
much excitement. All right, Billy, hi.
You still there,
Oh
Billy?
no, Billy was
We
there.
lost Billy.
Okay.
Oh, you're back. Okay.
So I created a pair of Mickey Mouse ears using the Adafruit Gemma MO. So it's hard to see, but there we go. And some WS2812 pixel rings and a little battery, also from Adafruit.
That's great.
Basically, the idea was to replace the non-existence of a pair of Mickey Mouse ears that my fiance liked at Disney World with something that I made. Got a little toggle button to actually change the programming.
Ooh.
So you can switch it around to different modes.
Looks great.
That's good.
This is way better than what they sell at the Disney store.
And eventually the idea will be to cover it with some fabric to cover up the LEDs, diffuse them a little bit so they're not as bright. This is actually at 60% brightness, running off of the 3.7 volt, 1200.
Oh.
And I also put in
You're starting to cut out, Billy.
Sorry?
You're starting to cut out, but I think we got most of it, though.
All right.
All right. Well, there's plenty of room. If you can hear us, there's plenty of room on at least one of these ears for Asking on the Show and Tell sticker, which I guarantee you no one at Disneyland is giving out.
Email support at Adafruit and we'll send you a sticker. Come back when you've got the fabric on it. We'll take another look.
Cool. Thanks.
We'd love to see you again. Thanks,
Great
Billy.
work. Okay. And
Dan and Mia.
Dan and team, wrap it up in 1 minute and you can do this.
No, you're muted.
Yeah, I got it.
Okay.
Yay.
Okay. I'm sure everybody's seen Cosmos and whatnot before. This is a Cosmo regular case that's normally designed just for one Cosmo. You'd normally have one guy here and then the charging base and then the cubes going across. Well, we have two Cosmos, so of course a redesign. I'm making portable smaller versions of the chargers instead of these big guys or this big thing. It's going to have a pair of these along with a 10 amp battery pack. So it can literally just charge on the go, and you need a battery power source for the Cosmo to start. Otherwise, it's a paperweight. So no matter where we are, we can start it up and we can play. Mia and I.
Awesome.
That's super cool. All right.
Right.
Well,
Good hack.
there's room on any of those things for a show and tell sticker. So you know the drill. Email us and we'll send you out a sticker.
Awesome. Thanks much.
Right. We got through everyone. Thank you.
Perfect
Phil, Dan, Pedro, Lon, JP, Dan, and Billy, and all the other folks that were on. We're here every week, 7:30 p.m. Eastern Time. Ask an Engineer starts in a minute. And thank you,
Thank you,
everyone.
everybody.
for making this
emails for your stickers.
the best 28.5 minutes of our lives every week.
Stickers.
Bye-bye.
Bye.